Hello everyone, this is my Kaggle assignment 2. I have run this cell to find the links for train CSV and test CSV. I have done the necessary inputs for pre-processing models, splitting and tuning as well as for metrics. And then I have loaded the dataset using the previous link using pd.read CSV, and these are the first 5 rows of the train data frame. We can find that there are a number of features along with the target column, which is exit status, and then this is the test data frame, and we can see that it also has the same columns except that it does not have the target column, which is the exit status. Now we are going to fit a dummy classifier and predict based on the dummy classifier. Now coming to data exploration, we find the shape of the test data frame and the train data frame. Train data frame has 90,000 rows. Test data frame has 30,000 rows. In test data frame, because we don't have the target column, we have 13 features. In train data frame, because we have 14 features. Now coming to identifying data types using .info, we find that there are 7 float, 6 integer and 3 object data types for all the columns. Now we can for all the columns whose data type is an object, we can find the unique categories, and we find that for the last name we have 2611 unique categories. For country we have 3, France, Spain and Germany, and for gender we have 2, which is male and female, along with the respective counts of all of these, and the data type of all of these. So the data type is actually an object, but the list that was presented, the data type of that list is actually int64. Now coming to descriptive statistics, we can use .describe and transpose it to find the details such as minimum, maximum, mean and median for each of the numerical column that has been present. So for all of these, we can find mean, standard deviation, minimum, maximum, 25 percentiles, 50 percentile and 75 percentile. And then we can find the correlation of the numerical features. We have not taken hash card and is active because they basically have values as 0 and 1, and based on these correlation values, we can find that between some of the pairs of these features we have a positive correlation, and it has been described over here. And based on all of these, we can conclude that as the age, account balance, production count, estimated salary and tenure increases, the credit score also increases. Now going to duplicates, we can first start by dropping ID and customer ID, because with these unique values we wouldn't really be getting any duplicates, and then finding the sum of all the duplicates using dot duplicated dot sum, and then dropping those duplicates and checking once again to see if there are any duplicates, and we find that previously there were 5, but now there are no duplicates right now. And then for missing values, we use dot is and a dot sum to find the number of missing values in each of the column, and then we can do dot sum again to find the total number of missing values, which is 27,697, and we can deal with these missing values in the pre-processing part. Now coming to outliers. In outliers, we are first going to find the numerical features and categorical features using dot select key types include dot columns, and then in the numerical features we are not going to use has card and is active, because they basically have values 0 and 1, and we are going to use the remaining features. and then find the outliers using dot quantile 0.25 and dot quantile 0.75 to find the first and third quantile, and find the interquartile range using third quartile minus the first quantile, and then finding the lower bound, which is first quantile minus 1.5 times interquartile range, and upper bound by third quantile plus 1.5 times interquartile range, and then finding all the outliers, and this is the count of outliers in each of these numeric features, and to deal with them we are going to drop them. And coming to visualization, we first take the histograms of all of the numeric features, and find that credit score and age are normally distributed, and production count has three unique values, 1, 2 and 3, whereas has card has a lot of people who have card compared to those who don't. And in is active, the number of people who are active and the number of people who are not has a very small difference between them. And in exit status, we can see that a lot of values are 0. And then coming to the pie chart of the countries, we can find that a lot of countries are actually France, followed by Spain and Germany, and then we do a bar graph to find that in two of the genders, female and male, a lot of people actually have card. And then coming to the feature engineering section, we first divide our train data frame without the ID into X and Y, and this is the shape of X and Y. Then these are the columns that we find in X. We can see that the target column, which is X status, is not present over here. Now in pre-processing, I mentioned before that we are going to deal with missing values. So we get back the missing values and find that we have missing values in credit score, country, account balance and production count. So for country we use mode imputer, and for the rest using simple imputer, and for the rest we use mean as a strategy for simple imputer. And then for the encoder part of it, we are going to encode the categorical features, which are last name, country and gender. We are dropping the last name because it usually does not have any relationship with the target column, which is the exit status. And for country and gender, we are one hot encoding them, and we are going to scale the numerical values without numerical features, without has card and is active. And then we are going to create a pipeline, and this is the pipeline with the imputation, the encoding and the scaling. Now as mentioned before, I'm going to drop the last name and then split X and Y into train set and validation set, and these are the shapes of them. Now we are going to fit transform, use the pipeline to fit transform on X train and transform on X val. These are the first 5 rows of the transformed train data set. We use maximum absolute scalar for scaling, so we can see that a lot of values which have been scaled have values between 0 and 1. And then we have one hot encoded the countries. So when we had 3 countries, France, Germany and Spain, when Germany and Spain have value 0, it means the country is France. Then we have also one hot encoded gender. So if gender male is 0, that means the gender of that person is female. And we have left has card and is active as the same as everywhere. And now coming to the model building part, we have taken all of we have imported these models at the start. So we are going to train these 7 models: logistic regression, support vector machine, perceptron, stochastic gradient descent, k-neighbors classifier, random forest classifier, and decision tree classifier. And for each of them we are going to fit on the train and predict on the validation, and then find the accuracy, precision, recall, and F1 score. Then we are going to sort them in the descending order of F1 score, and we find that the three classifiers with the maximum F1 score is random forest, k-neighbors, and logistic regression. So we take one of them, random classifier, fit it, and find the classification report, and find that the recall is very comparably very low for class 1. And even when we form a confusion matrix display, we see that a lot of ones have been predicted as zeros, which means there are a lot of false negatives. So based on that, we are going to do hyperparameter tuning on the top 3 models. We have done it for random classifier, and so we have had the param grade. We have used randomized search CV and put the scoring as recall, so as to improve the recall of the minority class. And these are the this is the best estimator with their best parameters. And then we are going to predict and find the F1 score to be 0.64. We do the same thing with k-neighbors classifier and find the F1 score to be 0.55. We do it with log-reg and logistic regression and find the F1 score to be around 0.56. So based on this, because random forest has the highest F1 score, we are going to select that and use it in the model part of it. So before that, we are going to use the pipeline to transform on the test data frame, which has been dropped of the columns ID, customer ID, and last name, and find the first 5 columns to be as follows, and then use the model to fit on the transform set and predict on the test set. And then whatever prediction we had, we are going to submit it to the submission.csv. So this was my Kaggle assignment 2. Thank you.